Well, hello everyone. My name is Maria Tikhonova,
My name is Alena Fenogenova.
and today my colleague and I we are going to talk about controllable text style transfer approach. Well, basically, first we will briefly cover the general overview of the modern controllable text style transfer approach, talk about this field, and then we will switch to our experience and to the things we do in spare devices. So as far as I understand, we have 20 minutes, yeah? So please, could you raise your hand after 10 minutes so that, yeah, we have 10 minutes. Yeah, that's perfect. Thank you. So basically starting from the problem statement, what is textile transfer? The task of textile transfer is to either generate text in a specific style, for example, positive, formal, negative in the style of Pushkin, and so on and so forth, or to paraphrase the original text in the specified style. For example, once again, we can rephrase the text, making it more positive, negative, more simple, or even more complex. In this talk, we will mostly concentrate on the second a problem statement, namely, we will mostly talk about the paraphrasing the text with the preservation of the original style. And speaking about the styles which can be used for textile transfer, there are quite various. And for example, I will name just a few of them, like formal and informal. We can make text less toxic or more toxic if we need to do so, more positive, negative, and so on and so forth. Like poetic, we can specify the style of a particular person, and so on and so forth. And you may ask us, why do we ever need to do this? For example, we can use these in the intelligence board. For example, in spare devices, we have our digital assistants, and each of them has their own particular speech style. For example, Joy is a young and positive woman who speaks rather informally, while Afina, the other digital assistant, she is a woman who speaks more formally, and she likes to speak about some philosophical things. And that's why, in order to make our chatbots more emphatic, we need to be able to mimic this style. In addition, it can be used for automatic text simplification, as I've already mentioned. It can be regarded as a text style as well, and so on and so forth. And today, as I've already mentioned, we are going to concentrate on one particular field of textile transfer approach. Namely, we will talk about the controllable textile transfer approach when we train or create a language model, which is conditioned somehow on a specific style. And speaking about the research which has been done in this field, the pioneer in this field is the work CTRL, where the idea is to create a language model conditioned on the control codes. And speaking about the way how we do this, they realized this idea. If in the standard traditional language modeling, we have like the model which models the probability of the next token conditioned on the prefix, then in the CTLR, we also add this control code. So basically, we generate the text conditioned not only on the context, but also on some control code. And basically, the CTRL model learns the distribution P from X conditioned on C by training on sequences of the text prepended with this control code. So this was the pioneer idea, and which that idea was further developed in the JEDI method. Yeah, the authors, they say that the method is pronounced like JEDI, despite the fact that it is written in the other form, but they insist on this pronunciation. And so basically, JEDI develops this idea in the form of modeling these condition probability. Namely, the idea here is to use a small language model, which conditions the generation of the big for the guided generation of the big language model. Basically, they use the two language model. One, which is a big pre-trained language model, which is not fine-tuned specifically for this particular style, but can generate the text or even paraphrase it. And the second one is a small language model, which is fine-tuned as a classifier called JD classifier. And basically, they use the bias rule to combine these two probabilities and to guide the generation of the bigger model. So let us look at some formulas, how they do this in terms of mathematics. Once again, they switched from standard language modeling to the conditioned language modeling. And moreover, they rewrite this conditioned probability in as a product of two terms. The first term comes from the probability of the main language model, which is not fine-tuned specifically for this style, but can generate the text. And this, and as for the second term, you might ask us how they model it, and they propose to use the bias rule and to use this JD classifier to model this probability P of the style or of the control code conditioned on the prefix. Lucky for us, the bias rule allows us to do so using this formula. And in addition, they add some details like normalization for robustness, for example. Speaking about the JD training, they introduce a special discriminative loss and combine it during the JD classifier training with the standard language modeling loss. This discriminative loss pushes further away the classes and thus improves the quality of the original classifier. Basically, this idea was further developed in the para-JD approach, where the authors proposed to use this idea not for the text generation, but for the paraphrase of the original text. When we have some input text and we want to paraphrase it in the specific style. Basically here, we use not the language model, but the paraphraser, which was pre-trained for the paraphrase task, and now it can rephrase the text in some neutral style. And here we need the JD classifier, basically, which once again models the probability. And by the way, an interesting particularity that here the JD classifier, it doesn't actually use the information about the original sentence X. However, it uses the information about the text which has already been generated, conditioned on a specific style. And once again, the idea here is to train the JD classifier with the two losses, namely the discriminative and the generative loss. And for the training, we do not need the paraphrase task at all. Basically, we are training our JD classifier for the classification task. So basically, this approach proved to be quite fruitful, and the experiments with the para-JD showed that it was well suited for the detoxification task and many others. So speaking to the next approach of the controllable text style transfer is the D-experts, namely which stays for the decoding time control text generation with experts and anti-experts. And basically the idea here resembles the Jenny approach, but the authors propose to use not only two models, but the three models, having not only like the JD classifier, but having the two expert and anti-expert. And so basically their idea is combine the predictions from expert and anti-experts. Thus, they augment the probability of the words in a specified style using the expert model, and they decrease the probability of the wrong words which are not suited for their style using the anti-expert model, which is quite good. And one interesting particularity of this approach is the generation procedure. Basically, when they sample from this model, they simplify the generation using the truncated logits, but basically they are reweighing with these experts and anti-experts only top k logits and set other to minus infinity, and that they do not just take into account, which simplify the computation, which is quite important in this field. So basically, the experiments prove that such approach even outperforms JD on on the texticity task, and their model is quite efficient in terms of computation. And the last approach I would like to briefly mention is the CF approach, which is quite basic and simplified method for controllable text style transfer, but it may be useful in the case if we do not have many resources and we want to do something simple which achieves reasonable qualities. Basically, they use binary reweighing of language model logits using an external classifier. So the idea, once again, it resembles the JD approach where we have the main language model and we reweigh it, its weights with some classifier, reweigh its predictions with some classifier. However, here Saif relies on a free-form classifier, which is much more simple because we can just take a pre-trained classifier from Hugging Face and that's it. Basically, they use some simple classifier, and once again they adopt the idea from the experts and calculate this probability only for top k or top g logits. So basically, once again, the approach can be expressed in the 3 steps. First, they obtain the probabilities from the main language model, then they reweight from the classifier and sample from top k logits. Once again, the experiments proved that the approach is quite fruitful and can be used, and the advantage of the approach is the simplicity, that the computations are not that time consuming. So, and that brings us to our experience, which we do in spare devices, and I'll let Alena to talk about it.
Yeah, Marie, thank you. Yeah, among all the models that we discussed today, for our experience, we tried the para-JD model for 2 tasks. The first one is rewriting in some semantic task. So we want to rewrite text, preserving their meaning, but in a new style. And this new style is actually classical task of the classical task of sentiment analysis. So here we want to rewrite text in positive or negative. For this task, we have chosen the training data for the JD classifier. There are 4 of them. It's a standard sentiment data sets: Rus anti-tweet, Rus sentiment, Kazakh's new data set, and Ru reviews. So they're all from different domains, all for the Russian language, and we balance these data sets, make them from different domains and different lengths, and filter it a little bit to make it better for the classifier task. So here we wanted to train JD on positive and negative classes. For this task, we took as a base model for a paraphrase model Ruti5 large. We took for the fine-tuning a multi-domain set of 7,000 examples from different text lengths and different domains. And this paraphrase model fine-tuned, and used as a base model for ParaJD task. For the JD classifier was also based on the RUTI-5 large model, especially for the case that both of these models, yes, the main and the classifier one, should the same vocabulary recognizer. So we used both RUTI-5 large models here because we didn't want to make problems with some incompatibilities or something else. Yeah, this combination of two models, yes, it's our ParaJD model. We evaluated it on a human eval for style transfer and for automatic metrics. For automatic metrics, we used the standard generation metrics such as CRF loss, BERT score, BLEU, Rouge, Lebesgue. This is for semantic similarity scores. And we have also used Rucola classifier. Yes, this is a special classifier for linguistic acceptability metrics, and some stylistic models for evaluating their style. We used Dostoevsky library to check if we catch the style. And especially we made a human evaluation. We created a design in Yandex Toloka for style transfer task. We asked talokers to check the origin sentence, the just paraphrased one with our paraphrased model, and the generated sentence from our ParaJD model. And this third sentence, third text, were also evaluated on different coefficients of styles. So the example you can see on a slide. And what we have found out is that you can see that if we make the style more expressed, we see that their sense scores are reduced. But at the same time, if we make the style, the coefficient of style more, people can understand that, yeah, it's a real positive style. And you can see on examples, yeah, we can really see that the JD model works, yeah, on a style. But at the same time, the ParaJD part of this is actually a little bit decreased. Yeah, here's the negative examples. We can see from the slide on the right side that people also evaluate the negative and see the difference between slight negative and express negative very good. Yeah. The second our experience with ParaJD model was on the task of text simplification. Here we formulate the task as text simplification problem. Yeah, we want to reduce the linguistic complexity of the given text fragment, but to improve readability and make it easier to understand. So here our specific style is simplicity task. So we want to make a JD classifier, our discriminative model, trained it on simplicity, complicity classes. For their experiments, we use the dataset from the shared task RuSimple-SciEval. As RuSimple-SciEval was presented by the organizers based on translated version of Russian of English wiki data, we filter this version of train and def competition data, and yeah, this filtered version we used for our JD classifier. So our experiments were the following. The first, we evaluate just paraphrasing model, the model that was actually used on the previous experiments with sentiment style transfer. Our paraphrase model was trained on 7,000 paraphrase examples, and that's it. Another model was fine-tuned paraphraser, so we used the same paraphraser but fine-tuned it on a simplification train set from from root simple interval. And the third model was fine-tuned Rooty5, also raw Rooty5 model, but fine-tuned on simplification frame set. And the last one, our case para-JD classifier, para-JD model. So JD classifier that was fine-tuned, that was trained on simplification trend set, and used over the paraphrase model, the first one. And we can see the results here, the comparison with the top 3 solutions of simple interval, and we can see that all our models actually beat the results from the shared task, and para-JD shows pretty good results, but we can also see that paraphrase itself actually simplify text. So it's maybe a little bit cheat to use this paraphrase as a base of para-JD solution, but still, the results are pretty interesting. So what we can see that controllable text transfer task can be used in various generation paraphrase task. We have discussed modern controllable text transfer methods. And we can see here that all of them actually have this combination. One governing model and one main model, and the second one that guided the generation of the other. And we can see that para-JD method successfully models the sentiment style and actually very good at text simplification task as well. You can check these results and try it yourself with our bots in Telegram. Please go through these links, press the buttons,
please play a little bit with these bots.
Thank you. Dislikes, whatever you want.
And please do not forget to press likes and dislikes, because we need your feedback, like training on the feedbacks proof to be fruitful.
So this is our contacts. We will be glad to hear your feedback, especially for our bots. Thank you.
Thank you, Masha and Alena. It was a really nice talk. I think we have time for a short question, maybe. Anyone? If no one ventures, I would like to. Alena, you have mentioned that while you're training the paraphraser, sorry, not paraphraser, JD for Russian, para-JD, is the transfer for the negative is worse than than the positive.
Actually,
it's the same. Okay.
Just good that people, the human evaluation shows that the style, the express style and slightly expressed style are different, actually.
Okay. Sorry. Thank you.
Thank you for the talk. So I have a question related to the previous keynote talk by Natalia Lukashevich about sarcasm detection and irony. So anyhow, do you take into account that there is an irony or sarcasm, and the paraphrasing, does it involve sarcastic or ironic sentences?
Thanks for your question. Actually, we haven't studied this field yet because the sarcasm is quite difficult to model and detect, and even people do not always understand whether it is sarcasm or not. For example, I'm very bad at detecting sarcasm myself. But yes, this is the idea for the future research, because of course, to model the positive and negative style, we need to mimic the research, and maybe we will combine it with some classifiers or detectors of the sarcasm.
Thank you.